So those of you coming D period tomorrow, please don't forget. It'll take you 10 minutes to wrap it up, and I definitely want to get those quiz grades in for this week. All right, let's check homework answers from last night. Where did they go? Whoa. Oh, up here. There we go. Want me to turn the lights off? Would that make it easier to see? Start correcting. Let me know how it goes. If there's questions on, wait, why? Let me know. I don't think it said to. Nope. So for 1 through 6, we just needed to identify AH and K and what did it do. No mention of domain and range in this set. Questions on 1 through 6? Yes. Where? Which one? For number 1? No, because we remember that our parent function is A, absolute value x minus h. So you actually have a built-in negative. So if I see a minus a value, it means that a positive number was actually plugged in right there. It's when I see something like this, x plus 4. How did that 4 become positive in number 3? A negative 4 was plugged in right there. Good question. Other questions 1 through 6? We're good? Can I scroll down? Yes? Which question? Which number?
3.
So 3 and 6. Here it's -1, and here it's 1 for A, yes? So remember, positive and negative just affects if it opens up or down. If my A value is 1, has it become more wide or more narrow? No. So it maintains the same width as the parent function. It's just opening up or down. Good question. Can I scroll down? So for 7, 8, and 9, let's just briefly talk about what these notes mean. A negative A value means it opens down. If it opens down and it's been shifted down, visually picture what that means. It's opening down and has been shifted down. Will it ever cross the axis, x-axis? No. Now, number 8, I have a positive A value, so it's opening up, positive 5, so it's opening up. I have a negative K, right, -3. So it's been shifted down and opens up. So how many times will it cross the x-axis? Twice. Here I have a -1/2 for A, opening up or down? Down. What is the invisible plus K right here? +0. So that means the vertex is sitting where? Right on the x-axis. So how many intercepts is that? Just 1. So if you use words on 7, 8, and 9, I'm just as happy with that. I don't necessarily need to see negative A, negative K. I'm fine if you say opening down, shifted down, no roots. Opening up, shifted down, 2 roots. Opening down, no vertical shift means it's on the x-axis, 1 root. That would be totally okay. How do we do with 11 and 12? Do we want to do 11 and 12 together from start to finish? All right. So let's talk about number 11. What does 11 say? Give me the... Now, evaluating is something we touched on just a little bit, so now we'll really talk about it right now. What are you asked to find? Good. Is this giving you an input or an output value? Input, meaning you have something for x or something for y. Right. So we're going to come over here and say f of negative 10 equals negative 3. So wherever I see x, we're substituting in negative 10. That doesn't look like a negative 10. Let's fix that. Ah, what is going on here? I was all excited about writing 10, right? I forgot my 6. What? See, this is why we use the Mobi. No, I was just saying, hey, let's change it up. Shouldn't have done that. Okay, there we go. What are we going to do first? Inside. So absolute value bars, you can treat them kind of like parentheses. If there's something inside those bars that you can do first, you need to do it first. So this will be negative 3. What is now inside those absolute value bars? Negative 4. And I still have the minus 5. What is the absolute value of negative 4? So this becomes negative 3 times 4. My bars have now become parentheses because I took the absolute value. What is negative 3 times 4? Negative 12. Minus 5 is negative 17. Good? Let's talk about 12. What does 12 say? And it says f of x equals 8. Are you being given a value for x or a value for y? Y. The y value. So literally, where I see f of x, I will be substituting in 8. And we need to solve this. We need to solve this for x. So take a look at that for a second. No different than if this was a linear function and I gave you f of x equals a number, you would still be substituting it in that output position where y goes. So let's solve this together. What can we move first? What? No, you just pick up the colors. No, but it won't. Okay, now what? How many people got it that far? If not, work with me on it now, and then let me know what questions you have. Question? You good? Are you taking notes? Okay. So let's talk about what we do from here. What's the absolute value of 3? 3. What's the absolute value of negative 3? 3. So this kind of has a connection. You know when you're solving x squared equals 81 and you take the square root, you get 2 answers? Same principle here. Because I need to figure out what's going to make x minus 4 equal 3 and what's going to make x minus 4 equal negative 3. Because if what's inside these absolute value bars equals 3, what's the absolute value of 3? 3. If what's inside here equals negative 3, what's the absolute value of negative 3? 3. So here we will always break it up and we're going to have 2 answers. So over here when I add 4 to both sides, I get x equals what's x equal for that one? 7. And what does x equal over here? So let's test them out. If x equals 1, what's 1 minus 4? What's the absolute value? Negative 3. 3. And if x equals 7, 7 minus 4? 3. So for these, when we are substituting in for the output and solving for x, With absolute value functions, we will always have two answers. All right, very good. We're going to add just a little bit more to our notes. What is the objective for today? What are we going to learn how to do by the end of today? Graph. Graph and write. Back to the Moby, because clearly the smartboard and I do not get along. Would anyone like one or two more solving questions before we start graphing? It would take us like 5 minutes. Okay. So once you have it written down, I'll solve it up here, you solve it, and then we'll compare answers. Because we're actually solving for y. I have actually nothing to add over here. So because my actual function started off as y equals, as soon as I'm done doing this evaluating, I actually get my answer. So the question was, why do we not move 8 over? It's because we have nothing actually to add it to, and it's not needed since I actually started off with an equation that said y equals. So y is already by itself for me. Do we match? Yes? Any questions on how we got -6? All right, number 2. Number 2 says 6 equals 2, Just by looking at what we're starting with, how many answers should we end up with? 2. Very good. Can someone tell me what I should do from here? Yes. So as soon as you have isolated whatever's inside the bars, this is when we break it up to be our 2 different equations. So I have x plus 4 equals a positive 1, and x plus 4 equals negative 1. Good? Ask questions. Who matches what I got? Yeah? Taisha? You all set? Good? Malcolm's all set? How are you doing? Setting up the 2? Good question. So let's reason on this. So if I have, ultimately I know I'm equaling 1, right? What's the absolute value of 1? 1. What's the absolute value of negative 1? 1. So the fact is, there is a value for x that will make the inside equal 1, and there's a value for x that will make the inside equal negative 1. So I have to find both of those x values. So we do that by setting up x plus 4 equals a positive 1 and x plus 4 equals a negative 1, and we solve for each. And then we can check, right? Let's see. What's negative 3 plus 4? 1. That's this one right here. And here, what's negative 5 plus 4? Negative 1. So by setting up these 2 equations, you are finding the value of x that makes the inside 1 and the inside negative 1, because we know that when we take the absolute value of 1 or negative 1, we will get out 1 as an answer. Good. One more. What do I do from here? Can I set up my 2 equations? Are my bars by themselves yet? No. Yes, we have a negative 1 right here, so we're going to divide both sides by negative 1. So now I have 8 equals, negative 8 equals absolute value of x minus 7. Now that my absolute value piece is totally by itself, there's no coefficient in front, I'm not adding, subtracting anything, now we can set up our 2 equations. What are our 2 equations going to be? Now, question for you. Will this ever equal negative 8? Think about that, because we didn't do anything wrong, right? We added 5 to both sides. I got a positive 8. Divide by negative 1. I have something in absolute value bars equal to a negative. Can that ever happen? Can you ever have something in absolute value equal negative 8, equal a negative? Think about that. Can that ever happen? No. So as soon as you have this happen, the first thing you should do is go double check to make sure you didn't make a sign error. But if you didn't, it means no solution. There is no value for x that will ever make this true. Ever, ever. Okay, good. Let's switch over to graphing. Tomorrow's stamp question will be 2 solving. We'll keep solving in the mix so we can continue to get comfortable with it. Graphing. Graphing is awesome. It really is very direct in how we approach it, okay? To graph, step 1. Identify and plot the vertex. H, K. Step 2, use A and negative A to count use A, so positive A and negative A, to count to the next points on each side of the vertex, using A as the slope. So I do have a graphing example, but that I'll hand out in a second. Let's just consider a rough sketch. That's it, by the way. These are the only 2 steps. That's it. See, I said it was going to be awesome. Example 1. Y equals negative 1/3 x plus 2 plus 1. What do I need to identify first? What is the vertex? Careful. Negative 2, comma 1. So again, as soon as I see a positive value here, we remember that this was originally x minus h. So that means that a negative 2 was plugged in there. So I've identified the vertex. What is A? That is all we need to sketch a graph. So let's sketch a coordinate plane in our notes. What are we going to plot first? The vertex. So I go negative 2, 1. There's my vertex. Now this is the key, is using A as a slope. So from here, let's first use it just the way we see it. So what would this mean as a set of directions for slope? What does this mean? Down 1. Yep. Right. 1, 2, 3. Can I do it again? Can I go down 1, 1, 2, 3? Hold on one sec. To get literally reason, how am I going to get my other side of this function? If you did the exact opposite and went up one left, that's going to be a linear function. Is this a linear function? No. So now, instead of going down 1 and right 3, we're going to go down 1, left. So down 1, 1, 2, 3. And we can do it again. Down 1, 1, 2, 3. And we're done. So we've got our vertex at -2, 1. Should it be wide? Yes, because if I look at A is between 0, the absolute value of A, 1/3, is between 0 and 1. So it's more narrow or more wide? More wide. So I have my vertex here. What's my axis of symmetry? I know, right? We have that invisible vertical line. X equals -2 would be the equation of my axis of symmetry. Domain, all real numbers. Range, good. It's not bad at all. 2 steps. Vertex, A, you're done. We're going to take a step into the real world and join Bruno Mars at a concert. It's very exciting. I know, right? Come on, that would be a great concert. There's 2 in there for them to make sure it loops today. Come on. So the mini golf question on the front, that will be part of tonight's homework. Realize that the reason the graph looks the way it does, what quadrant, let's make an educated guess, what quadrant are we working in here? 1. So if you like, you can actually create this. We're working in quadrant 1 on that first example. We're going to focus on Bruno Mars on the back. Bruno Mars just released a new album. Weekly sales S in millions increased steadily for a while, then decreased as given by this function. Let's define variables. What do I have for variables? Careful, T and S of T is what it's looking for. So we're not going to talk about AHK yet. Let's look at that. What's T represent and what's the output represent? How is time being measured? And then once I know how many weeks have gone by, what output do we know? The sales, and how is sales being measured? Millions. Okay, there we go. Now we have our variables. Let's reason on what this graph looks like. Look at the function and what can you tell me about its shape? It opens down and it's going to be more wide. So let's actually sketch that. It opens down and it's going to be more wide. Now with this picture, it really helps us to appreciate what B is asking. After how many weeks do sales begin to decrease? What point on the graph will represent that answer? The vertex, right? Because as time goes by, sales increasing, at some point it's going to hit a max amount of sales, yes? So we need to find the vertex. Happens at vertex. Do we need to do math to find the vertex? No. Nope. What's my vertex? Now the question is, which of these values is the answer to this question? I recommend actually giving a real world label. Is 12 T or S of T? So actually make a note. Weeks. And this 43 represents sales in. So now that we have these little labels, let's reread the question. After how many weeks do sales begin to decrease? Sales begin to decrease after 12 weeks. What is the greatest weekly sales earned? Yep. That was their peak sales. What is the vertex? 1243. And now we're asked to draw a rough sketch. So literally rough sketch. So 1243, somewhere right there. And you already know what two pieces of information about the graph. See if I can get it to look even a little wider than that. What label could I put on the x-axis? Label. Number of. And what's on the y-axis? That's it. So there's two pieces to homework tonight. Miniature golf is one. You can start working on miniature golf now if you choose. And then graphing practice. When you look at miniature golf, will it be negative infinity to infinity for the domain? It will not. What restrictions do you have? 0 to 20. So that will come into play on that one. And you can see what we have.
Today is October 13th. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God,